Hello everyone. So in this video, we will be discussing implicit differentiation. So in this video as well, we'll be discussing some examples of how to derive or how to differentiate implicit functions. So from the previous sessions, we've already discussed some overview of what is implicit and what is explicit. So again, explicit function, these are in the form y is equivalent to f of x, where y is said to be an explicit function of x. So it is said to be explicit if our y is separated from the variable x. So as you can see from here, we have y with equivalent to the function of x. However, in implicit function, if y is a function of x but is not expressed explicitly in terms of x, then y is said to be an implicit function of x. So just like here. So as you can see, y is already not equivalent to f of x, where y is already combined with the variable x. So this is where we'll be deriving the function implicitly. So some examples would be find the derivative of b squared x squared plus a squared times y squared is equivalent to a squared times b squared, where a and b here are not variable, but these are constant values. So the same, we'll be applying the same standards, the same process in deriving. So this one, since this is a constant, we'll be deriving x squared. We'll be copying the constant and then deriving the x squared, in which the derivative of x squared is 2x, right? So that's 2, copy the constant, b squared, then we have the x. So the same as here. However, in deriving an implicit function, if we are deriving y, we have to put y prime at the end of it, or we have to multiply y prime to its term. So a squared, that is constant, so meaning to say we have to copy this and we have to derive y squared. Now the derivative of y squared, the same way of deriving our x squared, but again we have to multiply y prime whenever we derive a variable y. So we have 2a squared y, and then we will be multiplying that with y prime. And for this one, since both of these are constants, so meaning to say derivative of a constant is equivalent to 0. So now we are looking for the derivative, and as we know, derivative is y prime or dy over dx. So as you can see from here, in this term we have the y prime, so we need to isolate this. We have 2a squared y, then y prime is equivalent to negative 2b squared x, because we'll be moving this term to the other side of our equation. Then to isolate our y prime more, to find the derivative, we have to divide both sides by 2a squared y, then same as here, 2a squared y. So this would be cancelled, so meaning to say y prime. 2 will also be cancelled from here, so y prime is equivalent to negative b squared x over a squared y. So this is now our derivative of the function. So I hope this example is clear. Now we'll move on to another example. We have find the derivative of y squared minus 3x plus 2y is equivalent to 0. So this is still an implicit function. So again, whenever we are deriving y, we have to multiply it by y prime. So derivative of y squared is 2y. Then we'll be multiplying by y prime. Then derive our term with x as is. Derivative of negative 3x is just negative 3. And then the derivative of 2y, So copy the constant, derive the y. And as we know, the derivative of y is 1. And again, we have to multiply each derivative by y prime. So we have 2y prime is equivalent to 0. Now we have to isolate y prime. So what we have left here is 2y y prime plus 2y prime is equivalent to positive 3 because we are moving this to the other side of the equation. Factoring out y prime because it is common. So we have 2y plus 2 is equivalent to 3. Now dividing both sides by 2y plus 2, 2y plus 2. So we have y prime is equivalent to 3 over 2y plus 2. Okay, so this is now our final answer. So the next example we have here, find y prime and y double prime of square root of x plus square root of y is equivalent to square root of a. So now we'll be finding, or we have to look for the first and second derivative of our function. So this case, we have to derive this one first. Derivative of square root of x is 1/2 x raised to negative 1/2 plus 1/2 y raised to negative 1/2. And again, if we are deriving a term with y, we have to multiply that with y prime. Derivative of square root of a, since a is constant, so that is just equal to 0. Then afterwards, we have to isolate the y prime, so we'll be moving this term to the other side of the equation. So we have y prime 1 over 2 square root of y is equivalent to 1 over 2 square root of x. Then we have to divide that by 2 square root of y. This one as well, 2 square root of y. So we can get our y prime. So now, division of fraction is we can multiply with the reciprocal of the denominator. So this would become 2 square root of y over 1, right? So cancel the 2, cancel the 2. So we have square root of y over square root of x, or basically that is y over x, square root of y over x. So this is now our y prime. Now we also have to look for our second derivative. So you may use either of the two. You may use this one or you may use this. So in my case, I will just use this in order for me to use the quotient rule. So in order for us to find the double prime, we have to use quotient rule. So this would be square root of x times 1/2 y raised to negative 1/2 y prime minus square root of y. That's v du minus u dv. So that is 1/2 of x raised to negative 1/2 all over the square of the denominator. So in this case, that would be x. So next one is to simplify. So we have square root of x y prime over 2 square root of y minus square root of y over 2 square root of x all over our x. Now afterwards, As we know, we still have y prime here, and we know that the value of our y prime is either this or this. So we have to substitute the value of our y prime so that we can remove the symbol y prime here. So let's multiply that with y prime. So we have square root of x over 2 square root of y times the value of our y prime, which is square root of y over square root of x minus square root of y over 2 square root of x all over x. So simplifying further, we can simplify this. We can cancel some terms. Cancel square root of x, cancel square root of x, cancel square root of 9, cancel square root of 9. So what we have left here is 1/2 minus square root of y over 2 square root of x all over x. So after that, these are still two terms. So we can combine this one, find the LCD. So in this case, our LCD would be 2 square root of x. So what would happen to the numerator here would become square root of x. And here, it's just the same, square root of y. Then we still have the denominator, which is x. So afterwards, we can divide the fraction by multiplying the reciprocal of the denominators. We have negative square root of x minus square root of y all over 2 square root of x times the reciprocal 1 over x. Okay, so after this, we have to combine this one. So this would now be equivalent to square root of x minus square root of y square root of x times x, that is 2x raised to 3/2. So this is now our final answer. Okay, so we still have one last example, which is to find the second derivative with points 3 and 4. So we have to find the derivative of this, the second derivative of this, and then we have to substitute the points that is given here. So 5x squared, derivative of that is 10x. Derivative of 2xy. So these are two terms. So meaning to say we have to use product rule. So product rule is u dv plus v du. So copy the u, which is 2x. Derive the v, which is y prime. Plus copy the v, which is y. Derive the u, which is 2. And then derivative of negative y squared, that is negative 2y y prime, and derivative of 13 is equivalent to 0. Now we have to isolate those terms that has y prime. So we have 2x y prime minus 2y y prime, and we'll be moving to the other side or transposing the terms that doesn't have y prime. So we have negative 10x minus 2y. Next is we have to factor out our y prime. So we have 2x minus 2y. That is equivalent to negative 10x minus 2y. Divide both sides by 2x minus 2y. 2x minus 2y. So our y prime is equivalent to 2 is common for all the terms, so we can factor that out. We have 5x plus y, because this is negative. Negative times positive, that would be negative. Then we have 2x minus y. Can cancel 2. So meaning to say our y prime is negative 5x plus y all over x minus y. Okay, so we can already find our second derivative from this one. So we have to use the quotient rule in finding our second derivative. So that's x minus y times derivative of our negative 5x plus y. So that would be negative 5 minus y prime minus our numerator, which is negative 5x minus y, multiply by the derivative of the denominator, which is 1 minus y prime. That is divided by x minus y squared. Okay, so let's simplify this. X times negative 5, that is negative 5x. X times negative y prime, that is negative xy prime, plus 5y plus y prime. Negative 5x times 1 times negative, so that would be plus 5x. Negative times negative times negative, so that would be negative 5x y prime. Negative times negative, that is positive y. Negative times negative, that is positive, times negative, that would be negative y prime. Now all over x minus y squared. So let's see if we can cancel some terms. So negative 5x and positive 5x cancelled. Positive y prime and negative y prime will be cancelled. And then we can combine some terms. Negative xy prime and negative 5xy prime, that is negative 6xy prime. 5y plus 5y, that is 6y, all over x minus y squared. After that, we still have y prime here, so we can substitute that with the value of our y prime. So we have negative 6x times negative 5x minus y all over x minus y plus 6y all over x minus y squared. So you can still simplify this if you want. So we can have this as negative 6x times negative 5x, that is positive 30x squared. Negative 6x times negative y, that is positive 6xy, all over x minus y plus 6y all over x minus y squared. So we can still really further simplify this, but since we have given points, we can already substitute that to the values of x and y. So that would give us 30 times 3 squared plus 6 times 3 times 4 all over 3 minus 4 plus 6 times 4 all over 3 minus 4 squared. So if we calculate that, that is equivalent to This is now equivalent to negative 318. Okay, so this is now our final answer. So since we have given points here, so your answer should also be in constant number. So I hope that you have understood the examples discussed in this video, and I'll see you again on the next sessions and on the next video. Thank you, everyone.